Hello explorers and welcome to another video. We're still in the game development month where I'm trying to build a game. I'm in a little bit of a game jam, and today I'm going to talk about the player character, the hero, and how it works, and also how the enemy in the game works. So first off, we're going to look into the the player character. And the player character needs a few things to actually interact with the world. First off, we need the actual position where we want to put the player at the start. Then we need the physics world. We need the width and height, half the width and height of the window, so we can calculate the position of the player and put the hero in the middle of the screen. And then we have some coordinates here, screen X and Y, and player X and Y. So that's where we want to position the screen and where we want to position the player within the screen. So that's the different coordinates here. And then we have a scale, and that's a variable I will use to actually show which direction the player is moving. So if you are going to the right, for instance, we will show the sprite in one direction, and then we will flip the scale. So if you have a minus scale, so you scale something with a minus value, you will actually flip the tile around or the sprite around. And then we have jumps, so I have a counter how many times the player has jumped. And then I have max jump, so that's how many times the player can jump before it must collide with ground. So that's if you want to build in double jump or triple jump into the game. And then we have some physics here. So this is the physics engine within Löve. And the physics world is something that we need to keep track on. We need to create a body for the actual physics world. And this is where we can see what coordinates the physics world actually have moved the character, and we can either say that this is a dynamic body, so it will be moved around, it will be pushed by physics. So if we have gravity, for instance, it will actually push the character down if it's dynamic. But if it's static, then it's a body that will stay in the world and not move around. You can still collide with it, but it's a static object in the world. And then this object needs to have a shape, so we create a circle shape with 32 pixels diameter radius, and we set these together into a fixture. And the fixture is what we actually collide with in the game. And we say that the body and the shape should be in this fixture, and we have a weight of 1. So that's the value 1 there. And then we set some friction to the world, so it will be a little bit more friction to the object. And then we set the user data to self. And the good part by setting the user data to self is the user data is available on the fixture when you collide with stuff. So you can look into the user data as your own object when you are colliding with stuff. And by setting that to self, you have the possibility of actually reaching everything in this object when it collides with another object. So I can actually check, is this a player object? Where is the player? What direction is the player going in, and so on, when we collide with stuff. So that's very useful to actually set the user data to self. And then I set up some sounds. I have a walking sound, a jumping sound. And then I need to keep track of how much time has elapsed, and that is used to actually figure out what frame should be shown in the animation. And then I set the current frame to 1, and I will fetch the player file. The player file is the actual sprite file with all the small images of the player character. And then I set up frame 1 and 2, and you can see and 3, 4, 5. But the first two here, the first image is the girl standing still. So that is position 0 in the XY direction and 8 in the Y direction, 32 wide and 48 height. So in that quad, you can find the actual pixels to show when the girl is standing still. And then we have new coordinates here, and that's when the girl is blinking. And then I have 3 quads actually telling me when the girl is running, what 3 animation frames should be shown during that animation. And then I set the active frame for that is shown at the moment, so it's the girl standing still. And then I draw this player file, so the actual sprite file I will give to draw, and the active frame, so it knows what quad of the image to actually pick out and show. And then I will draw that at the player X and Y, so the actual position of the player. So that could either be in the middle of the screen or a little bit to the left or right, depending on where we are in the map. Then I have a rotation value, and I'm not using that at the moment. I don't want to flip the player or rotate it forward or anything like that. I want it to be stable. And then I set this X scale by this variable, and that's because I want to be able to flip the image if we're going in a different direction. And then I set the Y scale to 2, so I want the player to be twice the size of the actual pixels in the image. And then I have a type function, so I can check if what we collided with is of type player. And then I will have a stop function, so if you're pressing down, the character will stop at that position. You might still have a force forcing the player in either direction, so it might not stop directly, but we are setting the velocity to 0, and if the force is still pushing the player, it can move somewhat, but it's a good way to, if you press it multiple times, you will stop eventually. And then I have 2 functions here, moving left and right. So I will check the velocity. I will set if we are moving left and the going right is false. And I will set the check if the velocity is not larger than 100. Then I will push the player in that direction. So that is because we don't want the player to hit maximum velocity or infinity velocity. So we want to set a range for that. Maybe 100 is a little bit slow. I can feel that the walking is a bit slow. Maybe I should have a sprint feature or something like that. It shouldn't be that hard to implement. Then I have a little function here if the player has actually landed, and that's collided with ground. If we collide with ground, we'll run this landed function and set jumps to 0. The jump function will check that we haven't jumped more than max jumps. We will increment the jump, play the jump sound, and then give us a push in the Y direction 400 up. So we will jump up in the screen. Then other things in the world and also the screen want to know where we actually want to draw the map. So the player decides where to draw things. And what part of the map should be drawn at the moment. So that's why we need to give the engine the X and Y coordinates so we can actually draw the right things. And in the update function, this is to handle all the animations. We will count how much time has actually elapsed. We will check the velocity, and if we have very little velocity in either direction, we will pause the sound, and then we will check if the current frame is 1, so if the girl is standing still, and then if more than 2 seconds has elapsed, then we will move to the blinking animation. And if we are in the blinking animation and 0.3 seconds has gone by, then we'll go back to the actual standing animation. So that will mean that the girl will stand still for 2 seconds, then blink for 0.3, and then stand still again. And then we have the other way. If we are moving faster than 10, then we will play the walking sound. We will look if the frame is the first in the walking animation, and if so, then we will check if the time has elapsed of 0.2, then we will go to the next frame and the next frame and then back again. And the last if statements in both of these is if we, for instance, have a value of the frame that is larger than 2 and we have stopped, then we will go back to frame 1. And if we have a frame that is smaller than 3, so we are stopped but we want to walk, then we need to move the frame up so we actually start walking. And then we will set the active frame. We will set the scale, either to 2 and the offset of -32, or if we are moving right, then we will set the opposite. And the offset is there, so we will actually draw the sprite in the right position. If we don't have an offset, when we flip the image, the character will move within the in the screen. So we will not flip the image at the actual middle of the sprite, we will move it at the edge. So that will look a little bit strange. So we need that offset. And then we have two if statements here. If the player is very close to the edge of the screen, we will figure out, or if it's not close to the screen, we will set the player X to half width of the screen plus the offset, and then we will actually figure out where we want the screen to draw. And we set a minus value because we want to draw the map further in, so less of a we will move the map where the player are, so we will actually show the player. And if we are close to the edge, we will actually figure out where the player position should be, not the screen position, if that makes any sense. And the reason why we have -64 here is because of the height of the player, so we will actually position the player to be on ground, because the player is, I believe, 128 pixels high, or see here, 48 plus 48, not really, but it's 48 plus 48 minus 32. So that's what this 64 is. So we will actually position the player on ground, because we have a ball, and then we will want to figure out from the center of this ball how much is it to the upper edge of the sprite of the player. So that's how this player class works, or object. So that's to move around in the world. Then we have the enemy. And the enemy also needs the physics world, and where it starts, we need an enemy position, where we should position the enemy in the world. We need a scale so we can flip the sprite around again. We need a size, and this enemy is actually 0.5 large, because the sprite was quite large and I wanted the enemies to be a little bit smaller. And then we set the offset of the enemy, and this is used on multiple places, so therefore I put some values up here, and that's to actually position the sprite correctly to the body. So again, we don't get any strange artifacts or the enemy walking on air or so on. And then we will create this dynamic little body here, and the circle shape, and so on and so on. Use the data to self. We'll set some sound. I'm not using those at the moment. There was a lot of walking sound if I had the enemy, the player, and everyone was walking around. So that will sound good. We have the sprite again, and here we have an enemy sprite and an enemy sprite's JSON. And that's because I'm using a little tool that could take a lot of images. In this case, I believe the enemy is 32 different sprites. So I could take all those images and then compact them into one PNG with this program. And the program also gave me a sprite JSON with all the coordinates where the different quads were. So that was quite handy, because then I could just load the image, load the JSON, run this little for loop where I get all the X and Y coordinates and width and height, and just put those quads in. So that was really nice in order to just create this animation without actually doing all the figuring out what position in the image all those sprites were. And then we set the active frame. We will draw the enemy here, and we get the actual screen X and Y here into this function. Another thing that you can look here is that when you're running a function in Lua, you actually get self into the function as well. So that could be good to know because I spent a lot of time trying to figure out why don't I get the right value here in my update function. Yeah, it's because you're running an update function on an object, and self will be the first variable, so you will get a very strange value if you try to get an actual numeric value. And the screen X and Y was what we talked about earlier, that the whole world is centered around the player. So we need to know where the screen coordinates are, so we can add those to our enemy X and Y coordinates, so we know where to actually draw the enemy. So that's why we send them in here. We have a type function. We need to know where the enemy actually is, and we need a stop function if we want to stop the enemy. I have a destroy function, and at the moment I only have a barrel that can be destroyed. Enemies can't be destroyed at the moment. I haven't figured out a good way to destroy enemies. I have to figure out that in the future. And then we have this move left and move right, and it's pretty much checking if we are not moving in that direction yet, then push it in that direction. And then we have a little jump function, and we will play the jump sound and actually do the jump. So this is from the player class, and at the moment I don't have any jumping enemies. Maybe the AI should jump in the future, I don't know. The funny thing with this is actually to iterate and actually figure out how you want the world to work. And then I have a velocity function because I use that a lot, so it would be good to have that function. And this little update function here, we will figure out how much time has elapsed. And this if statement here is a little bit interesting. I actually take the current position of the enemy, and then I convert that to an actual tile. Where is the enemy standing? And when I figured that out, which X and Y position the enemy is on, then I will take that position and I will calculate the actual map tile that is either in front of the enemy or behind the enemy or to the left or right of the enemy. And when I have figured that out, I will see if there is not a tile there. So if the enemy is moving over the ledge, if it's running out to nothingness, then I should actually stop. So I tell the enemy, you should not move. Stop here, because you are going to run off a ledge. And if the enemy is not moving fast enough in any direction, which is the next function here, I will look if the enemy should go right now, because I have a variable that checks if the next operation should be moving right or moving left. And if so, I actually move the enemy in that direction. And that means that when it comes to an edge and it should stop, then it knows that next up I should move in the opposite direction. So it will run back. And that will make the enemy run back and forth on different ledges, which is a nice effect. And then I have this little stop the sound if you are playing, because I don't want the walking sound to walk. I think I just put it here because when I updated the the game over and over again using lurkers, so it actually updated on the fly. I realized that was too much walking sounds. I just put this in to shut it up. So maybe I don't need that anymore, and maybe I can remove all the sounds. But I haven't really decided yet if the enemy should have a sound. Maybe I should have a sound if the enemy gets close or something. I don't really know yet. And here we have the actual frame of the running animation. And as we have so many frames, I actually check if 0.01 seconds have elapsed, so 1 millisecond, then change to the next frame. And this little if statement here checks if the last element of the table, so number of elements in the table, if that's larger than the current frame, then I will go to 1 again. And tables are from 1 to the last, whatever that is, 32 perhaps. And then I will update the elapsed time to 0, so we'll start the loop up again. And then we will set the active frame down here. I set the scale and the offset of the enemy, so we will actually position the sprite right, and also in which direction it moves. And then I will calculate the actual position of the enemy, and depending on the actual offset of the enemy. So this is what I wanted to talk about today. I hope that you found this interesting. Playing around with the game and changing things in this little engine is really fun, because you can really directly see what you are doing, and you can play around with different concepts and see if they are fun at all to play around with or play with if you are playing the game. And I hope that you learned something. I hope that you found this interesting. If you liked this video, give it a like, share it with your friends and colleagues. If you have any comments, suggestions, or anything, leave them down in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.